have about 80 stations in the Strait of Georgia and Juan de Fuca, and it takes us about a week to sample all of them. One of the reasons that we undertake this survey is we're interested in understanding the oceanography of the region, and by monitoring the ocean, we can identify changes that are occurring, which may be indicators of the ecosystem being at risk.
Line P is a series of set locations along a 1,500-kilometer line that stretches west from Vancouver Island. We sail Line P 3 times per year. The data we collect are used to study ocean climate, to learn about ocean circulation and currents, about the biology in the area, and much more.
The primary instrument that we use is a rosette, which we lower from the stern of the ship. So as we lower it off the ship and it descends from the surface to the sea floor, the electronic sensors are gathering data on temperature and salinity and fluorescence all the way down. When it gets to the bottom and we start to raise it, we'll stop. All right, bring her up to 150.
150.
We'll stay at certain depths of interest. We will snap a bottle. That will trap water at that depth, and we'll do that at several depths on the way to the surface. Then, when we get the rosette back on board, we take the water and we sample it into smaller containers with specific analysis to go to each one. Some is physical properties, like the oxygen. Others are chemical properties, like the nutrients. Others are biological properties, like the chlorophyll.
More than 50 years of ocean data reveals trends. We've observed gradual ocean warming along Line P, as well as lower oxygen levels in the deep waters along the line.
To give us an idea of what's living in the ocean at a microscopic level, we use nets that we tow vertically from the bottom to the surface. Each year, there's a spring bloom when the plankton take up the nutrients and there's tremendous growth. And this is important for the juvenile salmon as they migrate from the rivers through the strait to the ocean. Because if they can hit the strait when that food supply is abundant, they become healthier before they go out into the ocean, and that will inform us in years to come when they return to spawn what the fisheries quota might be. And so with this combination of physical, chemical, and biological properties, we hope to build a picture of what are the main processes that are at play in the ocean. We can use this information to develop and validate computer models that try and give us even more information on how the conditions are changing.
In addition to ship sampling, ocean scientists also have the benefit of Argo, an international system of more than 3,000 sampling floats.
The Argo program is now entering its maturity phase, and the data from Argo will be combined with observations from ships and observations from satellites to create a new array of oceanographic information products for use by mariners, industries, government, and the public. So now oceanographers can do what meteorologists have been doing for many decades, track for the first time the movement of water and ocean properties in the global ocean without having to use extremely expensive research vessels and being able to go in places and work in weather that would be inaccessible for those ships.